Once again, we're going to do another example of a proof involving angles. And this one we're going to also look at some things with bisectors of angles, which we haven't done a lot with yet. These are some good proofs to consider involving parallel lines as well. So in this one it says you're given that BE bisects DBA and angle 3 is congruent to angle 1. And you want to show that CD is parallel to BE. So we always start with the proof. What are you trying to prove? And think about how I can do that. And there really are a couple ways you could do it. One is you could show that 1 is congruent to 3. That seems like a pretty good way. Because if 1 is congruent to 3, then they are alternate interior angles. And so that would be enough to show that they're congruent to each other. Another way to show if C is congruent to angle 3 by corresponding angle postulate, that would work as well. On this one, it actually works out pretty easily to show that, well, first let's get our statements in here for the given, and then we'll talk about those statements. But once those statements are in there for the given, then the first thing you should always do is, if you've got a piece of information in the given that is very valuable, like a bisecting statement, then you should go ahead and tell us what that means. And if BE bisects BDA, that very clearly states, by definition, that angle 2 is congruent to angle 3. And so we can make the claim that angle 2 is congruent to angle 3, and that's just by the definition of angle bisector. Now, if you notice, you should always be looking, when you look at your next statement, and a very big clue when you see the same angle in two different congruences, light bulbs should be going off that a next easy statement would just be to claim that angle 1 is congruent to angle 2, and your reason for that is simply transitive property of congruence. And that's a very good one to look at. And then once you know that 1 is congruent to 2, you're pretty much done, as we talked about at the beginning of the proof, and that is because 1 and 2 are alternate interior angles. You can claim that angle CD is or line CD is parallel to line BE, and that's just by the converse of the alternate interior angles theorem. And if you notice, that one was actually a very simple proof, and this is one of those few proofs where there's only one way really to get to the answer. There's no other way that really makes a lot of sense. It was a pretty simple 4-step proof, but it utilized that definition of angle bisector to allow us then to prove that lines are parallel.